of all, I would like to welcome you at our webinar. And the first part is YCN presentation as always. I think many of you probably already heard it before, but let's go through it one more time so you don't forget anything. So the Young Ceramist Network is initiative of the European Ceramic Society, and we are sponsored by the Journal of Research Trust. And we are a nonprofit network that aims to bring all of you together who are currently doing research in ceramics. We are here for you to provide you a platform to build your own professional network. So we give you the platform, but the work is on you. To do that, we have the committee. Currently, we have Alejandro from Spain. Avais is our newest member, who is from Pakistan, but now is in Germany. Hi, Avais. We have Nicola from Belgium, who is now in the USA. Antonia, who is in Croatia, but now is in Finland and will be presenting to you today. And me, I'm from the Czech Republic, but currently I'm in the USA. So you can see a pattern here. Then we have our two amazing administrative officers, Veronique and Donatella, who are helping us tremendously in anything we do. So every time we have some event or something, we should be very grateful for them because it wouldn't be possible without them. And last but not least, Andras Kocian is the head of the Young Ceramist and Training Working Group in ESERS and is our boss. As you can see, even though we are based under the European Ceramic Society, we are a truly international network, and we aim to bring together everybody in the world doing research in ceramics who is also young. So what are the benefits? Through YCN, you can attend professional events, make contacts, form links between each other and also the industry. I think a great example of that is that at the next ESERS conference in Lyon this summer, we are organizing a career fair to connect between you and also with the industry. Through that, you can benefit from exchange of ideas and work experience and get information about funding and job opportunities. And finally, through all these activities, we are aiming at promoting research and innovation in the field of ceramics. Currently, we are at 5 platforms, and we also have our newsletter. So you can find us on Facebook, LinkedIn, Twitter, and Instagram. And our newest platform is Discord, where we are trying to be more interactive and really give you space to talk about whatever you want to talk about. So, for example, right now, if you are planning to go to Lyon in summer, you can join and discuss accommodation or how you're going to get there. You can plan your trips together, etc. And of course, there is the newsletter. You can subscribe to the newsletter at our website. We are still growing. We have some amazing numbers. So on Facebook right now, there's over 1,100 of you. On LinkedIn, over 1,500 of you. That's really great. And of course, Twitter and Instagram are our smaller platforms, but we usually receive very nice feedback to our stories on Instagram. All right, here's a short summary of our activities. It's mainly the newsletter coming several times per year. Now you're currently at one of our webinars, so welcome. We also have annual photo contest, and we have great project YCN representatives, which means that we are trying to get one responsible young ceramist in each country to spread the word about YCN. And of course, we are organizing student evenings, events, and there will be much more in the future. So here's an example of our newsletter. You can read the news. Also, we try to highlight other young researchers. We share invitations. For example, here's the career fair, and so on. Our webinars have a very broad range of topics, let's say. So there's everything in between something very research-oriented to something very practical. For example, how to get Chicks Trust funding for your research stay in Europe. And here is the photo contest. So if you are thinking about joining, please do. The deadline is 4th of July 2023, And we have 3 money prizes for the 3 best pictures. And also the best reward, of course, is that the winning picture, the first place, will be our profile picture for the next year on social media. And as you can see, the YCN representatives are truly all over the world, and that what I said at the beginning is really valid, because even though we are mostly from Europe, we are not only focusing on European researchers. So that's that, and there will be a new call for YCN representatives very soon, so stay tuned for that and apply if you are thinking about joining this. And last but not least, here is a picture from our last students' evening that happened in Krakow last summer, and we had really amazing attendance. We had 200 young researchers from like 650 conference participants. So you can see that our young community is going very, very strong, and we had some great time. And of course, our next event is already the next week in Aveiro in Portugal, that we are organizing together with Ines, or maybe Ines is organizing with us because she put really loads of work into this event. So this workshop aims at allowing young researchers to present their work and to collect feedback, to safely practice their talks and improve. And also this is connected with a competition. So again, you can win some nice prizes. And here's what's ahead of us. So as I said, ESAR's conference in Lyon in France will include the career fair. It will also include the YCN Students Evening. We are very much looking forward to that. And also there's going to be satellite symposium on clinical applications for ceramics and technologies in dentistry. And within the symposium, there will be Shenko's Match contest for young researchers to present their cross-disciplinary studies on advanced ceramics and technologies for dentistry. And that's it from my side right now about YCN. And sorry about the light. Oh, okay. And and now I would like to tell you what's going to be next. We are going to have presentation from Antonia and from Joanna. And if you have any questions, please write them down in the chat. There will be Q&A session at the end of the webinar. And now I would like to introduce our dear Antonia, who will be the first speaker, and who is currently Marie Skłodowska-Curie postdoctoral fellow at Tampere University in Finland. Antonia started her research career at the Faculty of Chemical Engineering and Technology in University of Zagreb in Croatia, where she finished her master's degree in 2016 and defended her PhD at the end of 2020. Her research is focused on finding new solutions in biomaterials for bone tissue engineering applications, and currently she is developing next-generation bone augmentation procedures. And during her career, she was visiting researcher at Tallinn University of Technology in Estonia and at the Center of Biomaterials and Tissue Engineering in Spain. Antonia published 23 research papers, gave 5 invited oral presentations at international conferences, and received a L'Oréal UNESCO Award for Women in Science in 2020. Antonia was a member of the organizing committee of the American Ceramic Society Winter Workshop in 2022 and 2023, and was a member of scientific organizing committee in the organization of symposiums at the conference and exhibition of the European Ceramic Society in 2023. That's going to be this summer, and 47th International Conference and Exposition on Advanced Ceramics and Composites in 2023 in Daytona Beach, USA, and also Ceramics in Europe 2022 in Krakow, Poland. She participates in popularization of science by writing part for high school book on the topic of biomaterials, by giving lectures in high schools and events organized by a student in Croatia, and by writing an article for the scientific populist magazine American Ceramic Society Bulletin on the topic of biomaterials substituted with metal ions. Antonio continues to be guest editor in the second edition of special issue of the journal Polymers on the topic of biomaterials for tissue engineering and regeneration too. She was also guest editor in the special issue of Open Ceramics, Young Ceramists in Spotlight, another YCN project. And last but not least, and most importantly for us, Antonia is a member of YCN committee since 2019. That's shortly about Antonia. And Antonia, please, the floor is yours. We are looking forward to your presentation.
Thank you, Sonia. Thank you for the introduction. Can you just confirm for me still, can you see it and can you hear me?
Yes, everything is perfect.
Thank you. So thank you all for coming to this webinar. My presentation is going to be divided in two parts. First part will be about postdoctoral fellowship, Marie Sklodowska career action, and the second part about a 4 bones project that I'm doing in Tampere University under this action. So the good news is that yesterday the new call for Marie Sklodowska career action has been opened, and the deadline is 13th of September this year. And on QR code that you can see on the right corner, upper corner, and you will see it on these slides, you can find this web page and all the information that you need and all the documents that you need for project writing. So what does this funding cover? It covers a living allowance, a mobility allowance, and if applicable, if you have family, long-term leave, and special need allowances. And these are contributions for the awarded researcher. And next, there is also funding for research, training, and networking activities, and management and indirect cost. And these are institutional unit contributions. So you have your salary, but also you have funding in your project for research, training, and networking activities that you wrote in the project proposal. And how much each point is in the value of the money, you can find in the working program of Horizon Europe on the web page, where you can use this QR code. So type of the fellowship, there are two types. There is European one and the global one. European one lasts from 1 to 2 years, and it takes place in the EU member state or Horizon Europe associated country. And the global one is from 2 to 3 years. Very first 1 or 2, you are in non-associated third country, and then you have return phase for 1 year in EU member state or Horizon associated country. And from 2022, there is novelty here, and this is that you can use also additional up to 6 months in a non-academic organization, which is a really nice opportunity because you can go to the industry then and implement your research and see how the industry works. And who can apply? So you need to be national or long-term resident of an EU member state or Euratom associated country. You need to have defended PhD before the deadline, and that there should not be more than 8 years from when you defended your PhD. But there are some also details, like for example, maternity leave doesn't count, so you can check that. Also, you cannot stay in the country where you want to do your project for 1 year in the last 3 years. So you need to pick, let's say, the new one. And from 2022, and I checked yesterday, this rule applies for this year too. So all the proposals that receive score lower than 70% in previous year cannot apply again. So make sure that you have good proposal, that you do not score lower, and then that you cannot apply. And what is the project structure when you write it? Actually, there are two parts, B1 and B2. B2 is mainly focused on your CV, while B1 has 3 parts, and this is where you mainly write your project. And first part is the excellence, and it takes most of the points, 50%. And here you need to describe that your project is ambitious, that it goes beyond the state of the art. So somehow you need to have a project that is risky enough, but doable. And you need to find this thin line and explain that to evaluators. Then a second important thing is that it needs to be multidisciplinary. And I was lucky enough that I'm in the biomaterials, which by itself is very multidisciplinary field because we need to know chemistry, biology, medicine, material engineering. So it was easy to me to explain a multidisciplinary approach, but try to think about it in your research, how you can have as much as you can. And then gender dimension is very important, and you have full document only on that you can read and how to implement it. And you also here need to think a little bit out of the box. So don't just write that your team will be 50% male and female. Try to think about something else, how to really implement in the research. How I did it, I implement that in biological characterization, where I'm going to use cells from the male and female donors, and also the rats, female and male rats, to see is there any difference. And then open science is very important. You need to show that you are following FAIR principle, and that your data is going to be open as possible and closed as necessary. And then next important thing is supervisors. So where you are finding your supervisor, hosting institution, try to find one that really fits what you want to do. Because even we are principal investigators in this project, and we are doing everything from the research to administration. But this is a training, and we are very young, so we need to have somebody to supervise us and help us when we need it, because this is a training that we in the future write bigger projects. And it is important that there is a two-way transfer of the knowledge. So here the communication with the supervisor is crucial during the writing of the project proposal and when you are doing it, because you need to see what your supervisor can offer you, what you are missing, but also what you can transfer to your supervisor, the research group, and host institution. So it needs to be a win-win situation. And last thing in excellence that is important is that you show that you have professional experience, competences, and skills. And here, okay, you need to have experience in the research that you plan to do, some in that field. But also try to think about other competences and skills and what makes you different from the others. For example, if you did not yet start, maybe you can start volunteering or promoting science beyond research community to the general audience. So you can show that you are thinking not only about your research. The next part is the impact, which takes 30% of the points. And here you need to describe how this project, why it is important for your career, how it will increase your employability later. So what it will bring to you. So what is your goal in the future, and how will you go to this goal, and Marie Curie will help you. I had a list of the things here, and for example, one thing, I was very honest, so I wrote that I'm not a good writer of the papers. This is not my really good skill, and that I will try to improve it during this project by having some trainings, and that's my supervisors are going to train me to learn how to write for high quality journals, and then I will later use it for other projects. Then think where you want to disseminate your results. Be specific about which conferences you want to attend, which papers you are going to submit your results. Also, are they going to have benefit for the industry after your project? And think about communication to general audience. This is very important, that they know what is the importance of this project and how it will affect, for example, their lives. And also, we should not think only about scientific impact. Sometimes we only think about that, but we need to think about social and economic one, and you need to explain that more. And the third part, which takes the lowest points, is the quality and efficiency of the implementation. Here you need to explain your work plan, assessment of the risk, work packages. You need to draw the Gantt chart, which is science for itself. And you need to describe the host institution, their capacity. So can they support you in your idea and your research? And also always check that this host institution that you chosen has a gender plan. This is very important. So when I was writing the project, the excellence and impact I had a feeling that they are good. I put a lot of effort in it. They were strong. And I knew that the third one is my weakest one. And I was right, because evaluators found this in assessment of the risk, which was to them very general. And also, I did not describe well how I'm going to be integrated in the team. So you need to really pay attention to every detail. And you can see that in this presentation, I bolded keywords. And this is what I did in the project proposal. So online, you can find this evaluator form that evaluators use it, see, can they find all they need to find in your proposal, and then bold that. And also use color. You can connect, for example, objectives and work packages. So you will connect parts of your project proposal, and it will make easier for evaluators to find these key points, and they will feel better and you will get better points. And then do not forget about UN Sustainable Development Goals. Try to find your research in these goals for 2030. Show that you know about these goals, that you are going in the same direction as the community. And if you are still developing idea, maybe these goals can help you. And do not stop here. Also check the targets. I choose this one because I was in the third goal, good health and well-being. And then I choose the target where I am, and I wrote that in the project. So I showed that I'm taking this into consideration. So this was the first part of the presentation. I hope that if you were not interested, that maybe you are now more interested in writing this project. It is a very good opportunity for us as young researchers that we actually make our own position. You know, sometimes it's hard to find the positions for us, and this is the way how to do it, and then you train yourself for the future. And the next part of the presentation is about affordable. So Marie Curie project that I'm doing entitled Personalized and Affordable Multi-Substituted Calcium Phosphate Scaffolds. And the goal is to prepare the next generation for bone augmentation procedures. As I said at the beginning, you need to have the supervisors. And as my field is very multidisciplinary, I had two. So for material development, my supervisor is Professor Erkki Livenen, and for biological characterization, Professor Susanna Miettinen. And when you are going to explore who are awarded projects, if you are interested in writing, you can always find all the information for each project description, and also you can find when it starts, when it's going to finish. So for example, of 4 bones now, we passed the first quarter. You can see where the project is done, where the researcher is doing this project, and how much money the project received. And then what was the inspiration for the topic? It was actually my PhD topic, which was development of the biomimetic materials based on chitosan and metal ion substituted hydroxyapatite. The idea is to fully mimic what we have in our bone, so fully mimic collagen type 1 and inorganic phase hydroxyapatite crystals. And even it is not fully proven, it is generally accepted, and there are more and more evidences that first amorphous calcium phosphate is formed in our body, then it transforms to calcium phosphate, and finally it transforms to hydroxyapatite, the most stable phase at physiological conditions. And these two phases are good because they can be substituted with different ions. And our body has a lot of ions substituted, and they're crucial in bone metabolism. So idea was to mimic the phase content and element content. And by co-substitution of calcium phosphates or multi-substitution, we can have at the same time different properties, for example, anti-cancer, osteogenesis, and antibacterial properties. So the first step was substitution with strontium in calcium phosphate. And you can see here when it was substituted with 0, 1, 5, and 10% of strontium, we had this three-phase system that I mentioned, what is happening in our natural bone. And strontium was homogeneously distributed in calcium phosphates. And what was determined is the increase in cell lattice parameters, because strontium is bigger ion than calcium, so this was confirmation that it is in the structure. And also, these materials are not cytotoxic towards human embryonic kidney cells. The next stage was zinc and magnesium. So we had this similar phase content when we substituted with zinc, but when we substitute with magnesium, there is a little bit of changes. With 5%, we have white leucite, which is calcium phosphate substituted with magnesium, and this is desired phase. Same as strontium, magnesium, and zinc were homogeneously distributed in calcium phosphate, and they were not cytotoxic. Because zinc and magnesium are smaller, they are a little bit difficult to substitute, and also the decrease in lattice cell parameters could be determined because they are smaller than calcium. Next thing that was checked was protein absorption of bovine serum albumin, because this is the first thing that is happening where we implant the scaffold in the body. And here you can see that absorption is, after 4 hours, it's good. It's around 45 to 50% for all the materials. And this is somehow connected to the charge, let's say, zeta potential of materials. For all these with zinc and magnesium, they are positively charged. Bovine serum albumin is negatively charged at physiological conditions, so this affects the adhesion, let's say, like that, absorption. Next thing that was checked was antibacterial properties, because zinc is known to have antibacterial effect. However, you can see here, so the green is the substrate, the calcium phosphate with the ions. Escherichia coli is orange, and Staphylococcus aureus is purple. And you can see that actually zinc did not show antibacterial effect in this case. And bacteria are negatively charged, so they also have better adhesion to positively charged materials, like in this case. And what was determined actually that zinc was not found at calcium site in the lattice, but probably it is located at a 2B position in the lattice, and then it is not so easily released, and then this affects the antibacterial properties. Later, we had another study that I will not present, substitution with strontium and silver, where we had negatively charged surface, and then this thing together with silver had really good antibacterial properties of calcium phosphates. The last ion that we chosen was selenite ion that substitutes phosphate in the structure. And again, we have this three-phase system, but octacalcium phosphate is disappearing at higher substitution because of the charge compensation. And what I want to highlight here is that before, so as prepared powders have shown the selenite ions in the FTR spectroscopy, and after the heat treatment, we cannot see it. And I put it here because this is the reason why, for example, selenite ion was not used in a 4-bones project, because after 3D printing, we need to heat treat samples, and then we will lose selenite. So just that I explain why later it will be excluded, even though it has really interesting properties. For example, for the healthy cells, 5 and 10% is too much. It causes cell death, but 1% has good properties for healthy cells. While for the tumor cells, 1, 5, and 10% cause cell death. So this 1% substitution gives this dual function. At the same time, it kills tumor cells and has positive effect over healthy cells. And then, as I said at the beginning, we wanted also to mimic organic phase, not only inorganic. So biopolymer chitosan was used as polymer matrix to obtain these highly porous structures, and then 30% of calcium phosphate was put inside. So first two scaffolds doesn't have these ions inside, while scaffold 1 mix has lower concentration of them, and 5 mix high concentration. After that, we wanted to see, does this ion help in osteogenesis? So does stem cells differentiate to osteoblasts, because they can go to different type of the cells depending on the environment, and we were interested in this one. And after 21 days of the cell culture, you can see that the scaffold 5 mix has shown significantly higher amount of BSP and DMP1. This is the markers for middle and late marker for bone regeneration. And then for formed tissue, you can see here bigger amount of the formed tissue when we have these ions compared to when we do not have. The same is for the collagen type 1 expression, this brown part here, and phosphate deposits here. After that, we wanted to confirm with perfusion bioreactor to simulate what is happening in our bone. We obtained similar results that show that really these ions have the key role in the bone regeneration. So actually, this is the image that I included in the project proposal, where I wanted to fastly show to the evaluators that there is a difference between substituted and non-substituted scaffolds. And these materials were inspiration for the 4 bones project. So only the selenite ions were excluded because I already mentioned why. And the idea is here to obtain the scaffolds for load-bearing applications, as this one that were obtained for my PhD were obtained for non-load-bearing applications. 4 bones is divided into 3 objectives. So objective 1 is material development. Second one is biological characterization. And the third one is demonstration for the personalized scaffolds. So what was done so far, all the materials were prepared. So first, in the powder state, substituted calcium phosphates. Then the CAD model was obtained. We 3D printed that, and now we are in the process of the characterization to see how different temperatures and different amount of the ions affect the properties of the scaffolds. And here I'm happy to introduce the team for the objective 1. So Joanna and Martin from Litos are our collaborators, and I'm happy that we have Joanna today with us. So I will not go in the details about any technology that we are using, because Joanna knows much more about Litos technology than I do for sure. So I will leave that to her. And at Tampere University, my collaborators are Stella and Erika, who are also working on another project, Ceram AM, which is also using a Litos printer, and they are developing the ceramics 3D structures. So this is the first CAD model that was obtained. You can see that inspiration was from the scaffold that I obtained for my PhD, and then you can play with the structure. For example, here it was different porosities were obtained, different pore size, and this is how they look after the printing. So I will not go into details. Joanna will say everything what the technology offers, but you can see that really delicate structures can be printed. And then the second objective is biological characterization in vitro, in static and dynamic conditions, and in vivo. And here I included this gender dimension that I explained previously. And here with Professor Jari Hittinen, we are going to work on a micro-CT to see bone ingrowth and vascularization after in vivo studies. And I'm going to work with Arjen and Rupe on biological characterization hands-on. The last objective is the demonstration of the personalized scaffolds, because this is why this project is, this is the main idea of the project, that we will use the real case model. According to this model, we will obtain CAD software and then 3D print this scaffold and show that it can be done with this technology. And here we are collaborating with Planmeca, with Pontus, who is director of the CAD and CAM solutions. With that, I would like to conclude my presentation. I'm going to invite you immediately for the second webinar that is going to be next year on all the results in the 4 bones, so before the summer. I hope you will join me again then. And if you have any questions, or you think that I can help you somehow, if you want to write your own project, please, you can always reach me by my email. So yeah, thank you for your attention. And now it is my really great pleasure to introduce Joanna Diaz, who is our second speaker. So Joanna in 2019 concluded the integrated master's in bioengineering with a specialization in biomedical engineering in the Faculty of Engineering of the University of Porto. During her studies, she did an internship in Pisa in Italy, where she tried to develop an elastic scaffold to mimic the intensile villi. During master's degree, she developed material that would treat bone infections and at the same time promote bone ingrowth. After her studies, she did an internship in Litos, and afterwards she started working at Litos as a junior material engineer. And now she is the person responsible for the biomaterials for bone applications, in this case, hydroxyapatite and tricalcium phosphate. And to this, I would like to add that I'm very happy to have Joanna today with us. Joanna is the person who taught me how to print on the Litos printer. So she's the one who showed me everything that I need to know. She is the one responsible that we have really good slurry, printable slurry with my materials. So I owe her objective one. So Joanna, the floor is yours.
Oh my gosh. Thank you very much. Thank you everyone for coming and thank you for having me. So yeah, I will proceed with my presentation. How do I wait? I need to share. Sure. Can you see it?
Still not, but maybe.
Not?
Okay.
Wait.
Now, Joanna, it is loading.
Now yes? Okay.
Now we can see it and we can hear you.
So as Antonio was saying, I work at Litos as a material engineer and I'm responsible for the bone materials. And today I will tell a little bit about my company, how our process works, and what materials can we print and where can you expect to find materials produced with our technology. So Litos is the global leader in the industrial additive manufacturing for ceramics. We offer a full 3D printing solution. So the printers, the materials, the software are both developed by us. And we also offer customized solutions. We are headquarters in Vienna, Austria, but we also have subsidiaries in the United States and in China. And worldwide, we already have more than 140 machines installed. Okay, so everyone knows ceramics, the traditional ones at least, based in silica and clay, because those are the ones that are present in bricks, tiles, and pottery. But high-performance ceramics have a different application than normal ceramics. But why are they so important? They have a very high hardness, a very high resistance to abrasion and to heat. They can be used up to more than 2000 degrees Celsius. They have a very high mechanical and dimensional stability. Even at high temperatures, the mechanical properties won't change. They have a very good resistance to corrosion and to oxidation, and also an electrical and thermal insulating effect. So basically, they can be used in harsh environments where other materials fail. But why are they so important in medical applications? Because they can be bioinert and don't show any reaction to the body, and also don't cause any allergic reaction. They can be bioresorbable and used as bone replacement materials. They have a very low thermal conductivity, which is especially important when compared to metal implants, because metal in hot environments can get hot, and it can be painful for the person that uses it. And with ceramics, that doesn't happen. They don't show any artifacts on MRI or CT scans because they can be used at very high temperatures. They are easy to sterilize. And also, they have a very high mechanical strength and good wear resistance. Okay, so what materials have we printed so far? We already work with a lot of materials. So from left to right, you have electroceramics like piezo ceramics that can be used for electrical applications. We have refractory ceramics like silica base for casting cores and also magnesia. We also have the typical structure ceramics like alumina, zirconia, silicon nitride, ATZ and CTA, and also carburet. And of course, the bioceramics like tricalcium phosphate and hydroxyapatite. And we also worked a little bit in the past with bioglass. So as you can see, we can use basically every ceramic. It just needs time to develop. And our strategy is to use the material as it is and adapt the technology according to the needs of the partner. Now about the technology. So similar to the other 3D printing techniques, we start with the CAD design and then we print a part. But this part is not yet finished because it needs to suffer a thermal post-processing. We need to burn the binder and then sinter the part to achieve full density. It's a two-step process, but it's the normal way of ceramics are processed. Concerning the CAD design, the three-dimensional structures like the medical implants, they are represented in the form of CAD models. They are visualized by triangular faces using an STL approximation. The CAD object is then virtually sliced into layers with a defined layer height. And those layers are then projected in the printing process using an optical system, and it will polymerize the slurry in specific places. But how does it work? As you can see in the scheme, we have an optical system, the number 3, underneath the bed. Then we have the bed, the number 2. That's the place where the light hits the material. And then we have the building platform, the number 1. It's where the part is built. And we also have a coating system that avoids the sedimentation of the material while printing, and a dispensing system that dispenses material automatically during the print job. This bed is it's transparent, so when the light hits the material, it solidifies because it's a photosensitive resin with ceramic particles filled in. So we expose the light of the layer in one go and we build it up layer by layer. So the building platform will move up and down, and we will pull the part out of the slurry. It's an upside down approach, and it's an advantage because we use a very little amount of material, and it's possible to make very fine details and very thin layers. Now the thermal post-processing. After printing, we have a composite. We have ceramic particles and a binder that holds the particles together, and this is called the green body. Then we need to burn off the binder, and then we are left with the ceramic particles, and this is the brown body. Then we need to compact those particles. We need to compact them to pull them together, and this is the cold sintering, and to achieve full density and the full ceramic properties. In the whole process, there is a shrinkage of the material of the part. So you can see in the picture that how a part will change during the whole process. But this shrinkage is a value that is calculated before and already added by the software to compensate for this phenomenon. So in the end, you will have the part the size you want. And in the end, we have the part with the final ceramic properties. Now I'm going to show a little video of the process of printing a skull implant. This is the coating system. We need to clean the part, and in this case, remove the support also. Okay, regarding the material properties. The Lithabone HA480 is the newest material from Litos for the manufacturing of hydroxyapatite parts. Compared to the previous HA400, it allows the production of patient-specific implants with a much higher wall thickness, up to 10 millimeters, and excellent mechanical properties, and therefore a better flexibility in creating patient-specific implants. The density and therefore the microporosity, they can be changed according to the sintering conditions, which is important for the resorption rate of the material. The Lithabone TCP380 is the newest material for calcium phosphate implants, but it's still in the research phase. So where can our materials be used in the medical field? I think the most important thing I can say here is that some customers have already the highest class for medical devices, that is class 3 certification, and in the United States, some also have the FDA approval for class 2. And an important achievement for us is to have our materials implanted in the human body, and that already happened in 2017. Here are some specific demo parts that we printed. So from HA, we have a cranial implant, a jaw bone augmentation, some cylinders, a screw and a scaffold, and a mandibular cage filling. And from TCP, we have a spinal cage, a zygomatic implant, and an ulnar implant. And for example, this is a jaw implant. So we have an outer cage made of the zirconia that is a load-beating material, and an inner part that is a mixture of TCP and HA, which is then biodegradable. Another advantage of the LCM is a possibility of making multi-materials. So we can combine ceramic with metals, and also ceramic with polymers. For this, we work with 2 vats and a small cleaning station, and we can print 2 different materials at once. This change of materials can be within 1 layer, so we can have different materials in 1 layer or in different layers. Here are some examples of a combination of poor hydroxyapatite and a porosity graded hydroxyapatite. This porosity graded is obtained with PMMA. So we have a layer by layer example where we can visually see the different materials in each layer, but we also have a change within the layer. So we have an outside structure made out of pure hydroxyapatite and a more porous scaffold structure inside. The first picture was obtained within the Gracer Lead project, and the second one was in collaboration with the Universitat Politécnica de Madrid. So the 3D printing of ceramic implants by LCM enables the manufacturing of highly complex medical implants and scaffolds. Hydroxyapatite and TCP are ideal for alloplastic bone substitute materials, as they show good biocompatibility and are resolved by the body. This offers the possibility to promote bone healing without having to remove the implant later. This way, LCM allows the creation of patient-specific geometries with defined porosity, coming up as a good alternative to the conventional processing techniques for the ceramic industry. Okay, that's it. I hope I could make this interesting for you and that you could understand what I do and all the possibilities that this technology can be used for. Thank you for having me, and let me know if you have any questions.
Thank you very much, Joanna, for a very, very nice presentation. I think it was very inspiring to see what your capabilities are and how far, how far this evolved, because it's truly breathtaking. Now, I would like to invite everybody to ask questions in the chat. I can see that we already have a couple of them. So maybe I would start with questions for Antonia. So we have a question. What is the particle size of the ceramic used in the feedstocks?
Okay, so I can talk about the particle size in my case for the powders that I obtain, and then maybe Joanna can tell more about the one that they are using for their materials. So the one that is in the 4 bones project is between 5 and 10 micrometers. This was the size of the particles.
Okay.
Yeah, Joanna, you can add.
No, I think for us they are usually below 50 microns.
Okay. We have a second question. I think this one was for Joanna, and Mutsundar asks about the particle size of the hydroxyapatite and TCP.
Yeah, they are usually below 50 microns.
Yeah, I see that the particle size is very crucial here, probably. Then we have a question from Joachim. During the post-processing, how large is the shrink?
That's
Joanna,
for me, Antonia.
It's for me? Okay. I
don't know if it's for me or for you, but that depends. That depends on the sintering temperature or the degree of filling of the slurry, and so that's
For example, what we did like at the beginning. So the first objective is that we will examine different sintering temperatures and then Joanna checked the sintering, the shrinkage for each sintering temperature with my material. So, and then we compensate that during the printing. So there is this shrinkage factor in the software that we put.
Yeah, we just print standard parts that without any shrinkage effect, and then we measure them before and after sintering, and then we add this value to the software to the next printing job.
Okay. So the following question from Mutsundar is, does the slurry preparation involves mechanical milling with ceramics, polymer, and water?
I'm not allowed to say about the way of producing materials. I'm sorry.
That's all
Yes,
right. Don't worry
that
about
say
it.
also nothing, because
Well, keep your secrets. Okay. Another question from Seema is, in case of hydroxyapatite slurry, what is the solid loading in volume percent?
I usually use 40.
All right. Another question from Joaquin is, what is the highest precision you can print with your printers?
That depends on the materials. Some can go really fine, like really micrometers, but that's not true for all materials. That really depends. Depends on the composition of them.
I think we have a question that's slightly connected to this, and it is, what's the minimum size of pores you can print?
Oh.
The pore size, I think I think it's 0.2 millimeters. If I'm not mistaken.
Yes, I think that this was also what we observed, like, because we also printed like different porosities, and I can confirm that this was the problematic one. Everything below that.
Yeah, sometimes the problem is not printing it, it's cleaning it afterwards.
Yes.
That can be a problem.
Yeah, all right. Zahid asked if it's possible to ask questions directly, but I think this setup only allows us to ask questions through chat. So please, Zahid, can you ask the question in the chat? Okay. Another question is from Yane about the polymeric binders. Is there any residue left after sintering?
No, after sintering, no.
Yeah. Again, we have a different question about the particle size. What's the D50 or D90 of the particle size distribution you use?
The D90 would go between D50, I mean, sorry, 1 and 4 micrometer.
Thank you. Then we have question from Dimitri, which is addressed to Joanna. When it comes to multi-material 3D printing, how do you adjust the sintering temperature of different materials by sintering additives? If so, do they affect the biological properties?
I don't work with the multi-material myself, but there should be a compromise between the two materials that you combine. You know, if one material cannot go up to, I don't know, a certain temperature, then you need to find a threshold. But I'm not the right person to talk about multi-material.
Sure.
It was really good webinar. Litos had like 2 weeks ago, Joanna, I think, or 3 weeks ago. It was like a really good webinar from Litos. Just on,
yeah.
Exactly. Yeah. So you can follow Litos on LinkedIn, and you can see you can see which webinars they have.
Yeah. Another question is again related to the particle size, and it's with 50 micrometers particle size, how do you achieve high printed resolution?
We treat our powders before producing materials.
Yeah.
Yeah, it is the preparation process. Unfortunately,
I'm not allowed to disclose your information about the procedure,
Yeah.
like how we prepare materials. I'm sorry.
That's all right. I think we
It is okay,
understand.
Joanna, because this is the latest technology. Litos is telling that, so this is the normal with the companies. No worries.
Yeah. Also, have you experienced problems with the delamination during printing or in post-processing? How did you solve them?
You need to. I haven't experienced that recently because we optimized the binder now. But for that, you need to do thermal analysis of the and see, analyze to avoid that.
Yes, thank you. We have 2 more questions from the chat. There are very many of them. It shows how interesting your presentations were. So
I think that when you have Litos, like then there is a lot of questions.
yeah.
When I was there, like when we had somebody from Litos, there is like big pile of questions.
Yeah. So Zahid asks, what is the effect of ion substitution on zeta potential of hydroxyapatite slurries?
Okay, so what I can say that, for example, that when we substituted with strontium and silver, we had different, for example, that I presented for zinc and magnesium, but we did not examine how it affects on the slurry preparation. So I cannot actually confirm which one is better. I don't know, Joanna, do you have any experience with zeta potential and then how it affects the slurry and development of the slurry?
No, I don't know. I'm sorry. I work with your powders, but I it's like one mix, I mix, and I don't know how to work.
Yeah, here actually we cannot say if there is any effect in this sense. So we did not. It was like what I can say, for example, when we had non-substituted and substituted one, it acted similarly, let's say.
Okay. So the last question we have in chat is if you can reveal the morphology of the hydroxyapatite or DCP particles used for printing scaffolds.
Our powder is has an angular shape.
Joanna, can you repeat? I think that it was like.
Yeah.
I said our powder has an angular shape. I
Yeah.
think it was a question.
Okay.
Yes.
And one more. What is the solid loading in 3D printing maximum solid loading percentage?
The maximum, I cannot tell. I don't know. For me, I usually don't go more than 40, but I would say between 40 and 60 maybe. Yes.
Thank you.
Because
Yeah.
then it gets really complicated to print, you know? It's not easy.
And also if it's very low, if it's lower, then the structure is not good enough. So we had, for example, Joanna, with my powders, we could not add.
Yeah, I
40,
had to
for
reduce.
example,
I had to
38.
reduce solid loading, yes.
Yeah, I can also imagine that it differs from material to material.
Yes.
And yeah. Okay. Can I have a couple more questions to Antonia regarding the preparation of your project?
Yeah.
I'm just very curious because this is always the hardest part for me. How do you actually start writing the project or start assembling the project?
Yeah. Okay.
Do you have any tips?
It is like I think, Sonia, that you have also experience in project writing, but it is a long process. So it was like 7 months. It took me 7 months to write it. Of course, I had my regular job, and this affects the time. So it depends how much you can put inside. But the hardest thing was the development of the idea, because you really need to, okay, you know what you know, and then you need to communicate with the host institution what they have, and then from that develop what you can do. So this was the hardest part, just to coming up with idea. And then next thing what I did, I read everything. I read all the documents, and this took so much time because there is so much rules. And then I watched every YouTube video, and I participated in masterclass at Tampere University and at some masterclass in Croatia for writing Marie Curie. So from each one, I took something, and it was like useful, but it is a long process. And the beginning is the hardest, and then it goes easier as it goes. I don't know, did I answer your question? Or
Yes, yes, you answered very, very well. And I would really encourage everybody to use the information that Antonia provided to you, because I think every time you join some kind of webinar or read something, how to write the proposal, etc., etc., everybody shares different point of view, and I think you really need to pick what suits to your project, and just to try implement everything into the proposal to be successful. So I really like that part.
I agree.
And
yeah, I agree, because for example, some things that I participated in, I did not have any advantages, but I did not know it before. Sometimes you are in the seminar of 2 hours that somebody is talking about their experience, and you can use only some sentence is useful for you, but this is enough. This is how it should be. You need to explore everything and learn, and so yeah, long process.
yes, my second personal question is that how are you dealing with implementing all the principles that are required within such project? Because I can imagine that must be really a challenge, and for many of us it would be something new. So once you get the project, how are you dealing with this?
Yes.
Do you have any tips and tricks?
So when during the writing the project, a lot of things were very new to me. So this is for the young researchers, and we do not have so much experience. Practically, we just finished our PhD, and we were mainly focused on the our topic for the PhD. So for me, it was very challenging to learn everything about open science, then gender dimension, and data management plan, career development plan. So all these things that I was not familiar before, I actually needed to learn. And also like the ways how you can communicate your research with general audience. So what are the rules here? Because this kind of the project needs to have the impact on the society. So by reading a lot, I gained like knowledge how to put everything together. But during the like now when I'm doing the project, the most challenging for me, for example, is data management plan. So administration of the project, data management plan, just to learn how to store data, the safety of the data, which I was not familiar maybe so much before, like how to safely store it, when to open your data, how much to open your data. So these are these small details that now I'm learning. Yeah.
Yes, I can imagine that being very challenging. We have last 2 questions. So one is from Avais, and he reads my mind, because that was the last question I had for you. And it is, how did you find your hosts, institution, and supervisors?
Okay. So unfortunately, Erka is now out of the committee. Now he is in the attendees list. He's not anymore panelist, so maybe he can also talk about this topic. So Erka was the committee member till recently, and I'm in the committee in the position from 2019. So we were a couple of years like as a volunteers in this community, YCN. And then one day Erka popped the question that if I'm interested to join them as Marie Curie, but then I need to write the project. And actually He was also Marie Curie Fellow. He was doing his fellowship in Italy. Erika, you can write anything that you want in the chat. He was doing his fellowship there, and he had a lot of knowledge and skills in this, like writing, and he helped me a lot with like tips and tricks. So he was the main reason for why I'm here, and this is why I have Professor Erkki Venen as a supervisor, because he's leading this research group. And then Susanna Miettinen, I found her because Erika sent me the link to one webinar that Susanna was organizing, and I was missing supervisor for biological characterization. And then after webinar, I popped the question and she agreed, so I was happy. Yeah. So this is how
that's
they found me and I found them. Yeah.
That's amazing how, you know, once you have your network, how, you know, there are some coincidences and then you end up here. So
Exactly.
that's great.
I think that by building your network from the early stage, this really helps in the situation like this when you have so much content. So I think that here YCN is really good for young researchers in the field of ceramics, because there is not so much of us, and it is good that we are so well interconnected, and then we always help each other. And this is also with the job. So there is so much members that ask us for the job opportunity, and then we found something and they now have a job. So it's good to build our network.
Yes, and I think also the Discord server, the YCN Discord server, is an amazing place where you can search for other people who may want to do something interdisciplinary. Or so
Yes.
please feel free to use that.
And also, if you want to find your supervisors, you know, it is not that somebody needs to approach you. You can also, like on the web pages of the universities, they really post when somebody wants to be supervisors for Marie Curie. So my situation maybe is unique. So most of people really need to find their supervisors. Yeah.
Definitely. All right, we have last question here from Mutsunder, and he writes, as 3D printing is a versatile technique for printing scaffolds or implants of desired shape, processing printing is a challenging part, I feel, due to stability of printed structure, due to cracking, bending during drying, etc. I'm wondering, does the shape of the particles, broad spherical flake, play a crucial role to avoid such defect after printing?
I would say so, yes.
Yes.
But there's also a search for the right powder. You know, there's a lot of trials before actually being able to make a slurry out of it.
Yeah.
It takes time.
For example, for my powders, it did not work that I put them in the slurry. So as prepared, they needed to be heat treated, for example. This was for my powders.
Okay. All right. So those were the questions. Thank you very much, everybody, for joining us. Thanks to both of the speakers. Your presentations were amazing. I really liked them. I learned a lot today. And I'm looking forward to meet all of you on some other YCN event. And have a nice day. Bye-bye.
Next week in Portugal, Sonia.
Next week in Portugal. I will be online. But I will be there with you online.
Thank you all for coming. Thank you very
very
much. And
Bye.
thank you, Joanna.
You're welcome. Thank you, me.
We were making, so today in the morning we had the trial, and we were making like fun that we have the same color even we didn't talk about it. So we started to think alike. Okay.